Hello, everyone. Happy Thursday. This would usually be the last day of the week, but since Monday was a holiday, we have a class tomorrow. Just wanted to give out that reminder. And this is probably going to be a theme. I want to start this lecture off with something that popped into my head right after the last one. A student asked me what the best way to study for the term test and the exam was. And first of all, awesome. It's cool that you're asking so early. And the second thing is that what I said was the best way to study is to practice, do the assignments. That's true. But assignments don't cover everything that we teach in this course, and I sort of waffled read the slides. But I thought of something way better, and it's the learning outcomes. These things at the start of each lecture. These are literally what the course expects you to be able to do once it ends. And every question in assignments and tests is based on one of the learning outcomes. So my real advice for studying is to first read the syllabus and basically go through the learning outcomes and make sure you can do them. So for example, build and execute programs from a command line environment. I might ask you for that command that uses Clang to compile a C program. This is getting into stuff later in the course, but define the pre and post conditions for a routine. You'll learn what pre and post conditions are later, but you could totally look at some code you've written for other courses and think about it and pretend that you're being asked, what are the pre and post conditions for this routine? And answer that question. So anything that says define, explain, list, those things will are particularly important because they're not as testable while writing code. But on the other hand, things like create, implement, for those, the assignments have you covered, and tests might make you write a bit of code by hand. So this kind of connects to the rant I had earlier about how it's impossible to directly measure learning, and the entire school system is a compromise around that fact. So you can and should pay attention to the medium of the assessment, in this case an on-paper exam. Combine that with the learning outcomes that we give you, and from those you could probably get a pretty good idea of what kinds of questions might appear on the exam and prepare yourself for those. So another thing that I wanted to do before getting into the main lecture is to goof off with arrays a little bit more, because there's some pretty wacky stuff that you could do, and it's one thing to see that on a lecture slide, and it's another to actually do that yourself. So, spoilers, I was practicing. We're going to make a new code file. I've already logged into Aviary. I'm going to log out and log back in again just to give you all time to do so following me. Pretend I just entered my password. Then I'm going to cd into comp 2160-instructor. ls, what do I even have? And I'm going to do a bit of file management. This also functions as a review of common, question?
I'm sorry, before getting started with the class, I do have a question regarding the assignment deadline.
Okay.
Is there a possibility, can we change the
Yeah, I meant to talk about that too. Short answer is no, unfortunately. I was there before the department changed due dates to 4 p.m. and I was like, that's stupid. I love working at 11:59. That's peak productivity hours. But turns out that change was made for the sake of tech support staff who tend to get lots of emails about password resets in the evening and have to resolve them. So yeah, I wanted to change it to 11:59, but wasn't able to. If it's any consolation, I posted it a day early due to the pace at which we're going through lectures. So you all have an extra day to work on it and can work late into the evening on Thursday. So sorry about that. Now, where was I? Oh yeah, was going to review some common commands by managing my pretty messy Comp2160 folder. So I'm going to make dir array example, and then move silly arrays.c into array example. Then I'm going to do the same with the executable file, but I don't want to type all that again, so I press up to get to my previous command. Move the cursor back, just edit text, easy. And just going to do the same for a to-lower example. So
I'm confused if the move command moved like from your computer onto Aviary.
no, that moves folders within a single computer's file system. To move folders or to move files from your local machine to Aviary, you would use SCP, which I think I used last lecture, but I'd be happy to demonstrate again. I think for now, we're going to just stay on Aviary, but there will be an opportunity to use SCP again later. I think in the meantime, you could check out man SCP. Yeah, so these are all the options, and then the important part is source, target, and yeah, I think I'll cover this in more detail later, but the short answer to your question is move just works on one computer. When going from one computer to the other, use SCP. Okay. Going to move into array example. So silly arrays was just a file that I made up before class to test what was going on, because I knew that accessing array indices out of bounds was undefined behavior, so I didn't have any guarantee that what I was thinking would work. Question?
Sorry, so does it move like regardless of where it is in Aviary, will you move in the current directory?
Yeah, the arguments to move are defined in terms of where you are right now. So move silly arrays worked because we were in a folder with silly arrays. But you see, I could also give paths that point to other directories, even though it's always defined with respect to the current directory. So I'm going to go into the folder that contains array example by doing cd ... And just to give the example, I'm going to move silly arrays back into Comp 2160 Instructor to demonstrate that you can move things that aren't in the current directory. So we see there's no sillyarrays.c here. You can move array example slash sillyarrays.c into the current folder. And that worked. Now I'm just going to move it back. Probably should have just retyped the whole thing. Okay, does that answer your question? Cool. So I think I was saying silly arrays was just something that I made up to verify that it works beforehand. This isn't the file that we care about, so I guess we'll do serious arrays. As always, I type vim to start the Vim text editor, and then the name of the file that I want to open. Seriousarrays.c doesn't exist, so that command ends up creating the file, serious arrays. The usual C boilerplate is next. We press I to go into insert mode, and then hashtag include stdio.h, the standard input and output header file. Entry point for the program, int main void. So we're going to define an array as well as some variables to the side of it. I mean, on either side. You'll see what I mean very soon. Like that. Oh, and we're going to initialize them, as is good programming practice. Oh, and you've noticed that since I'm now navigating through the text, I pressed escape to exit insert mode, and I'm now flying around at rapid speed. I can press W to go forward a word, B to go back a word, and then that makes us jump to the semicolon, and we can press I to insert before the semicolon. Now I'm just using the arrow keys to navigate like a chump. So let's print out what the variables, or what values we have at first, sort of as a sanity check. Remember that inserting variables into strings in C works a bit weirdly. We have a placeholder $D for an int. I believe D stands for decimal, and you can use similar placeholders to print a number in binary or hexadecimal. And then \n for a new line, because printf doesn't do that by default. Oh yeah, and we're not done yet. As another parameter, after the end of the string, we put in first variable. Now we're just going to loop through the array to print all of its values as standard stuff. And actually, just to demonstrate another thing that I want you all to do, I'm going to define a constant for the size of the array. Vim provides a nice bit of extra navigation help. Well, that's what Vim is for. Once you're in normal mode, which is the thing you go into insert or visual or command mode from. You could use the curly bracket keys on your keyboard to navigate you could think of it as by paragraph, by block of code, or equivalently jump to the next new line. Super useful for going through the file quickly. And now I'm going to also demonstrate a different way of going into insert mode. I'm going to type capital O to insert on a new line above the cursor, like that. So I'm going to use another preprocessor directive. I promise you I'll talk about the steps of compilation eventually. Define
array size
5. Weird syntax. The preprocessor is kind of like another language bolted onto C. In fact, I believe it's Turing complete, which means you can write any program you want in it. I don't know, that's kind of neat. So, escape to get out of insert mode. Navigating down, 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 down. B to go backward. Insert, backspace. Array size. And we'll do it again here. Array size. And we'll print the other variable. And the classic return, what was it, exit success? This code doesn't matter, but I may as well demonstrate things that are nice for readability. So we're going to compile it right now. We haven't done anything remotely silly yet. Oh, did you have a question?
Yeah. So will it not work if you don't include the return exit success?
It will work. It's just good practice. In fact, if we remove that, I'm going to press DD to delete an entire line. I'm going to, again, press DD on this aesthetically unsatisfying empty line. The program will still compile. It'll probably still work as intended, but we're going to get a warning because we defined the main function to return an int, and we didn't specify a return value. When that happens, the magic of C comes into effect again. It will just return whatever happens to be in memory at the place where it was going to write a return value. That will very often be 0, but it's not guaranteed to be that and very unsafe to rely on that behavior. Question? Yeah, like, are you asking that, like, as opposed to exit success? Yeah, exit success is a constant that is defined as equal to 0. So they're the same thing. I would prefer you all use exit success instead of 0 because named constants give your code more readability over magic numbers, but they will compile into the exact same code. So colon for commands, W for write, Q to quit. I'm going to be very repetitive about this because I think that's useful for learning new things. So to compile, do clang, W all, because we want to see warnings. Serious arrays.c. And actually, while we're on the topic, similar to omitting return 0 and finding that it still works but is kind of janky, I'm going to omit that -o serious arrays part, just to demonstrate that this will still work, but the file that the compiler gives us will have a boring name. Okay, a.out. Okay, our initial values are same, and interestingly, it didn't even give us a warning for the lack of return statement. Perhaps there's an exception for the main function, but in general, if you have a function that's supposed to return a value but doesn't, the compiler will give you a warning about it, and your program will probably be incredibly janky, but nothing will necessarily break. So we're going to get back into this. Actually, I'm going to delete a.out and use -o for the rest of this. Yes, I promise I am not deleting anything remotely important. Vim serious arrays.c. So now we're going to set some values. Let's say array at 0 equals, I don't know, 1. Question?
So is this Vim program automatically on Aviary?
No, and, actually, time to go on another tangent. I can demonstrate how to get it all cool like this, which will also require me to demonstrate SCP. So I think I'll do that as a little diversion, because the short answer to your question is no, Vim sucks by default, and I think it would be useful to show off how to make it not suck.
Like, how can you do this with no Vim? Like, write code like this?
Are you asking about maybe other text editors?
Yeah.
Good question. I think they have Nano installed. Yeah, so you can use Nano as an alternative. This text editor is quite a bit simpler than Vim. You could see it even has some instructions along the bottom, and you can navigate with the arrow keys and just insert text without going into different modes. It's cool.
It's functionally the same, right, for assignments and stuff?
Yeah, like the marker will never be able to tell which text editor you used. And to that effect, I talked about how you should learn Vim even just for the sake of being able to make last-minute edits on Aviary. While I still think that's a good idea, Nano might be even better suited for it because you can actually write stuff without memorizing insert, colon, write, quit, 4 different weird key inputs. And then to exit, very important to note that upwards arrow, I think it's a caret, represents the control key. So I'm going to press Control X and not save because I just inserted a bunch of garbage. And that was it.
I'll just ask, is there a save button there?
I think so. I'm not at all experienced with Nano for the record, so I'm figuring this out live, but Control O for write out looks useful. I'm just going to finish editing a little bit or do some more editing. Oh, this is gross. Tabs are misaligned, so I'm just going to have to manually put 4 spaces. Now we're going to start being silly. And I'm going to modify this line so that the values correspond to the indices. So now I'm going to try to just save it. Weird. So I'm going to do Mac format to get Unix line endings because they're a bit nicer than Windows line endings. No? Oh, okay, I just pressed enter after that and it seemed to work. And then once I pressed Control X to exit, it didn't complain, so that must have saved it. Yeah. So the answer is, yeah, use Nano if you want. There's also Emacs, which is the evil rival to Vim. I'm not even going to get into that. So next, we're going to get distracted, as promised. I'll show you all how to configure Vim as well, and also do a demo of SCP while we're at it. The whole Vim configuration thing means nothing if you're not using Vim, but the SCP example is very important because if you're using VS Code, you're probably going to use VS Code, you'll need to use SCP a lot. So first of all, I'm going to undo my Vim configuration. rm home directory /vimrc. That's the configuration file for Vim. And actually, I'm not brave enough to actually delete it. If something goes wrong, I want to get it back. So I'm just going to use move to rename it. And rename it to something like vimrc old. And now, if I go back into Vim, it'll look for a file called vimrc, find nothing, and Vim will suck. What the heck? Oh, it might have some configuration built in after all. I think I'm going to do the SCP demo no matter what, but clearly Vim configuration on Aviary is more intensive than I thought. I'm just going to do a bit of poking around. Okay, whatever. I think I remember when I took 2160, Vim had that syntax highlighting built in. Actually, if anyone in the class has tried Vim on Aviary, can you volunteer and say whether you have syntax highlighting without messing with any vimrc stuff? Oh, okay, so it's there by default indeed. Weird. So that means that the CS admins have already done some Vim configuration in a way that I can't control as merely one user. That's kind of neat. So I'm going to log out. I'm going to download the recommended Vim configuration file from the course website. It's in my downloads folder now. I'm going to open up a new tab and navigate to downloads. From here, going to my a user folder manually would be a real pain. I would go like cd dot dot slash dot dot slash dot dot slash dot dot slash dot dot, but I don't need to. I could just do cd tilde for the home directory, and it already knows that I want to go into the vim config thing. Cd downloads, and then the configuration file was a zip, so to unzip it on the command line, we'll use unzip, like that. I'm going to type it manually to give more time to anyone manually typing along. Notice that the file name has spaces in it, and to express that on the command line, we need to use a backslash before the space. That prevents the command line from thinking that multiple words within the file are actually different arguments being given to the command. So that's another good thing to know. Remember, the point of this tangent isn't necessarily Vim configuration. It's giving more examples of helpful command line techniques, particularly SCP. Oh, I was totally testing this out earlier, so I already have a folder called recommended Vim configuration file. Yeah, I guess we can replace it. Yeah. 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 Okay, phew. We're going to cd into this. So.
Is it just me or does PowerShell doesn't have unzip within?
Oh, interesting problem. So like, I'm a little Mac user. I don't know how Windows works. It's too confusing for me. Let's just Google it live. And also, like, when I use Windows, I use WSL, Windows Subsystem for Linux, which gives me access to a whole Linux system in Windows. Highly recommended. But it comes with the side effect of never actually learning the native Windows command line. Huh. Try out expand archive and let me know if it works.
I think it worked.
Okay,
It didn't give me an error.
cool. Can you list the files, which I hope was done by LS, and tell me if the recommended Vim configuration file folder is there?
Recommended Vim configuration file?
Yeah, okay, that sounds like it works. Thanks for letting me know about this. In CompSci, it's way too easy to assume that everyone's using Linux, but some people use Windows. That's crazy. So we cd'd back into this. If we ls, we can only see a README. That's weird. README isn't Vim configuration. But as a spoiler, this is now a lesson on hidden files. And vimrc, that file, the name started with a period, which meant that it's hidden from the user. So to ls, but in a way that shows hidden files, you give it the argument -a for all. So now we see the vimrc. We also see // and // for the current directory and previous directory. which kind of exposes some implementation details. I guess every directory implicitly stores some shortcuts to itself in the previous directory. Pretty neat. So what does the README say? I'm going to cat it so that we can refer to it while we type in other commands. This folder contains a hidden file called vimrc that contains several useful configuration changes for Vim. To apply these changes, open up a terminal, check, navigate to this folder, check, and copy the file to your home directory using the following command: cp vimrc home folder. Open up Vim to see if the changes were applied correctly. If you see line numbers, it worked. Pretty simple, but whoever wrote this, it was me, was a total dummy and forgot that Aviary exists. That open up a terminal bit is really load-bearing. We need to open up a terminal on Aviary. And once we do, that recommended Vim configuration file folder won't be there. So we need to transfer the file to Aviary, and we do that using SCP. Secure copy. The syntax for this is basically SCP source file destination folder. So you fill in the blanks. vimrc, your UMNet ID at aviary.cs.umanitoba.ca. A colon, because if you don't put that, it'll think that you're trying to secure copy vimrc to a folder called your UMNet ID at aviary.cs.umanitoba.ca. And that's dumb. I don't want a folder called gitz at aviary.cs.umanitoba.ca. So that colon makes it clear where we're copying it into. Then I'm just going to copy it into my comp 2160 folder. And away we go. Again, you'll have to enter your password. I didn't because I went through the pain of setting up an SSH key. Pretty recommended, very confusing. I could probably ask people or help people with that if requested. I want to also demo transferring files from Aviary to local, but I'm having trouble contriving a situation where we would ever want to do that. Let's download the array file that we've been working on. So I want to SCP something from Aviary to the current folder. So we take the familiar syntax SCP source destination and just switch around the source and destination. SCP your UMNet ID at aviary.cs.umanitoba.ca colon to specify where you're going. And then I think it was my user folder, comp 2160 instructor / array example / excuse me, seriousarrays.c. If I got the path wrong, it'll yell at us. And we just want to plop it here. Dot for the current directory. Please work, please work. Yes. Yeah, it's here. Please write down SCP source destination in your notes. This will probably get pretty confusing. I want to also explain a common pitfall that some students struggle with SCP. We are in the local computer. Everything is happening right here. And we're able to access Aviary by typing in aviary.cs.umanitoba.ca. When you're on Aviary and you want to access your local machine, that is, for all intents and purposes, impossible unless you know some distributed computing and you're on a web server and you have like a public URL or exposed IP address, then you could get to it. But I recommend not messing with that. The rule of thumb for this environment is that you can only use SCP on your local machine and just mix around the source and destination between Aviary and your local computer to transfer files either local to Aviary or Aviary to local. So I think next up is to get back on track with our array example, especially since that vimrc turned out not to be necessary on Aviary. So we're going to SSH. Actually, before we do that, I have been filled with regret. I do not want to CD array example right now, and I'm so busy that I can't take the time to just hold backspace and delete it. So I'm going to press Control-C, C not as in copy. I have never learned the official name for this, but I think C stands for cancel in this instance. You can press Control-C while typing in a command to clear that command. And I just want to check if the vimrc transfer worked. ls didn't show it, so I'm going to do ls-a to show hidden files. And yeah, it's here. I'm going to keep it in there and not do anything with it. Oh no, the tabs are wonky. That probably was part of my vimrc. So the Aviary default config, what's that? Yeah, and I didn't do that because I thought it was unnecessary and Vim was already tricked out on Aviary. But in a stunning plot twist, it turns out the vimrc was meaningful after all. It just superficially didn't seem meaningful because the syntax highlighting was still there. So I guess I'm going to follow through with the Vim configuration example. I also just noticed that there are no line numbers, which is also the thing I noted on the README, but whatever. Escape to get out of insert, :WQ. So vimrc is in the folder that contains that one. Contains the array example folder, I mean. So I'm going to cd previous directory /.vimrc and then copy that into my user directory. Ooh. Oh, I did cd. Should be mv. And now Vim should be cool again. Line numbers. I'm using the curly bracket keys to navigate by code block. Insert tab. Yes. Back into business.
Sorry, where did you move the vimrc?
To my home directory, which is denoted by ~/. pressing W to navigate by word. Actually, we can do so much better than that. You can jump into insert mode at the end of the current line by pressing capital A. So array size is 5. I'm stupid, so to get to the last index of the array, I'm just going to try putting in 5 because humans start counting at 1, right? Equals 5. So this is some pretty terrible code. I'm going to make it slightly worse by not adhering to a programming standard about not copying stuff. This is just an example, and I don't feel like writing a function for this. I'm going to press capital V to go into visual line mode. This is equivalent to like clicking and dragging through some text with your mouse. Select the whole thing. D to delete, which is also kind of like a cut. Go back down, and P to paste. Wait, I didn't want to delete that. Gotta undo using U. And here's something really stupid. I'm gonna undo too much. Again, I'm stupid. Oh no. How do you think you redo in Vim, considering undo is the U key? Any wild guesses? Because you're wrong. You'll probably think it's R, but it's Control R for some godforsaken reason. Vim's cool, it's just so weird. Anyway, P to paste. I did it. And let's see what the, what's that?
I'm still a little bit confused by like the arrays in C.
Oh yeah?
Like you declared it with size of 5.
Mhm.
Can you just walk through that, please?
Yes, definitely. I'm just thinking about what to explain and how. I think this might be well explained with a picture. Apologies to anyone watching the recording. I think I'll upload the pictures, anything that I draw, to UMLearn afterwards. So anyone watching from home or just catching up on the material can view them from there. So you might remember from the lecture that I said that memory is like a giant array, or I don't think I said this, but you could imagine it as not infinitely long, a really long tape of values, like this. These little squiggles at the end are to denote that it goes far beyond what I'm drawing here. And as a little simplification, gosh darn it, what's with this microphone? Real sorry about those noises. Creepy. I'm just going to turn this off and on again. Hello? Oh no. I think they got slightly less bad. We're just going to deal with it. Oh Maybe I'll invest in some noise-canceling headphones. What the hell? If this keeps going on for like more than a minute, I'm just gonna turn off the microphone and yell for the rest of the class. But we're gonna attempt to deal with it. Imagine memory as being divided into a bunch of slots. In the real world, memory is better explained as an extremely long sequence of ones and zeros, but we're going to simplify it a bit and say that each of these slots holds enough ones and zeros to store an int. You might remember from that cool Wikipedia article from last lecture, we can find out how many ones and zeros are needed to store each data type, but let's not worry about that for now. Each of these squares is like somewhere between 8 and 32. That was debilitating. Let me know if I need to talk any louder than I am. So each of these stores the equivalent of an int. In our code, we had 3 variables. I'm going to be a bit lazy because writing is a lot harder than typing. Second variable. So what that did on the memory tape is up to the implementation. This might work differently between compilers, but a reasonable guess of what it's doing and something that will hopefully lead into a good answer to the request to walk you through the creation of an array is that it put the variables in their place. So FV might be right here. R might be right here. And this is something that I really wanted to point out. Arrays are not objects. In C, there is nothing special about them. You're basically just allocating space for a sequence of variables. So this is R index 0, R index 1, R index 2, R index 3, and R index 4. And then SV might be right here. In Java, there would be a ton of stuff around it, such as pointers to methods for things like getting the array length. But in C, R is just a memory location that you access concrete values of by applying an offset to it. Does that satisfy what you're asking for, or is there anything else about arrays that you wanted clarification on?
I guess if you can go back to the code.
Pretty.
So you declared it of size 5, and I remember that the array of like 5 spaces.
Sorry, can you say that again?
So when it says int array size is equal to 0,
Mm-hmm.
line 7, did you declare an array of length 5? Is that what that did?
Yes. The preprocessor, this is, again, a sort of sneak peek into a later lecture of the course where I finally talk about compilation. the first step of compilation is the compiler noticing that array size is equal to 5, going through the code and replacing all instances of array size with 5. And then also worth noting is that I forgot a space here and that this equals bracket 0 bracket initializes all values in the array. So like all those tape squares on R and to the right of it to 0.
So that's good. And then when you're down to line like 17-ish, are you saying array at index 1 is equal to 1?
Yeah. Also check this out. I can skip to any line by typing colon and the line number.
So I guess in Java, if you made it like it's 5, it would be like 0, 1, 2, 3, 4. How does that different C where we can use index -1 or 5?
So I'll walk you through what those code changes do on the tape. So we did R1 equals 1. Array at -1 equals -1. And array at 5 equals 5. So the big takeaway, sorta, is that the indexing operators are just offsets of a memory location. So array at 1 equals 1 does exactly what you'd expect. Makes me kind of wish I used a pencil instead of a marker for this. Sets it to 1. Array at -1 goes 1 space back and sets that to -1. Array at 5 goes 5 spaces forward, 1, 2, 3, 4, 5, and sets that to 5. The C language trusts you way too much, and we are exploiting that. Any other questions about arrays?
Is it actually like still contiguous?
Yeah.
In FB and SB, is it still beside evenly?
Incredibly good question, because that is dependent on the implementation. So Clang will apply some sort of strategy. Other compilers, like GCC, will apply some other sort of strategy. And later on, in this example, we'll actually see that our assumptions about where FV and SV are located aren't necessarily correct. They are contiguously next to the array, but not necessarily in the way we're expecting here. So yeah, the answer is it depends.
So if we're like, I guess, not careful with our like choice of indices, we can just overwrite previous stuff?
Yes, yes, yes. It's so fun. And this whole example is to warn you not to do that. So we're going to get out of here and save our work. Compile it again. -O because we care about the file name now. Warning, warning.
What if series array.c already existed for the output? Is it going to overwrite?
Yeah, like, I'm going to do this again. This won't be a very meaningful example because I've made no changes, but I'll compile it again, and that will overwrite the previous instance of serious arrays. Yes?
What does the syntax mean, like playing wall series array dot c, or what does the dash o do?
So Clang is a compiler, of course. Wall means warning all, so show all warnings. I don't know which warnings in particular it triggers, but if I do this, it might not show the array index warnings. Okay, it still does. Still recommended that you use WAll, but I guess that applies to categories of warnings other than array indices, I mean. This is your input file. -O means set the file output, the output file name. If we omit this, it'll just give us a.out. And then this is the output file name to go with -O. Also, I believe this is in the slides somewhere. Previous lecture. But there, it is somewhere. So I think that covers everything about this command. So I guess I'll move on. Compile it a third time. And you know what we say to these warnings this time? Yeah. Going to Control C out of that because I'm pretty sure the nerd emoji is not a valid command. And we're going to run it. So, what do we have here? Oh, I'm just going to edit this to make the output a little nicer. And because I'm using bad programming practice, I need to duplicate this change across duplicated code. So I'm going to press YY to copy. Why it's not CC, I have no idea. Actually, I have something of an idea. Y stands for yank. But why they use yank instead of copy, that I have no idea about. And then I'm going to try to paste it. OK, phew, that works. So what I just did was add a line between the sets of printing. And I'm going to write after silly changes. Compile it and run it. So array 1 was 1, as we hoped. Actually, I'm going to try and pull up the code next to this. Aha, it just barely all fits. So this worked exactly as intended. Array -1 equals -1. Well, first variable is 0, as we initialized it to. But second variable is -1. And then array 5 equals 5. That modification is nowhere to be seen. So what it turns out we did was we did set array 1 to 1, but our negative index actually ended up affecting second variable. And array 5 equals 5. We wrote a 5 somewhere into memory. You have no idea where you just wrote a 5 to. I certainly don't know. And that's dangerous. We might have overwritten a return address, so some function will now return 5. We might have overwritten, question?
Yeah, if those square brackets after the ARR, if they're performing some underlying point arithmetic, wouldn't the 5 be right next to the 4?
Yeah. Excellent clarification. I wrote,
3 is,
yeah, I wrote -1 here and nothing in particular there, but it would have been much more accurate to say that it turns out FV is stored here. And SV is here, set to -1. Good catch.
okay, that makes sense. But that would make FB 5 then, right?
Let's see.
If FB is exactly after the open.
Oh, yeah. Good catch again. I don't know where FV is.
Randomly, yeah.
So what we've run into here is called undefined behavior. The C standard, to my knowledge, doesn't apply any restrictions on where exactly variables should be stored, especially relative to each other. And I do know for sure that it doesn't impose any requirements on what should happen if you give an invalid array index to something. This means that each compiler is free to do whatever it wants with those situations. Hopefully, it responds to array -1 with going 1 to the left, but it technically doesn't have to, and you should not rely on any particular implementation of this undefined behavior. And as another little tangent, undefined behavior is what makes C fast. Things like not having to do bounds checking. In Java, before every array access, it would check whether the index is in bounds. In C, it just does it. It trusts you. So this is actually a pretty big takeaway. I hope you guys remember this when you go into industry. There's a trade-off between safety and speed. C takes the speed route. So we have about 5 minutes left in class. I think we have just barely enough time for me to show you something that is not even that important, just kind of dumb. This won't be on the test. Talking about arrays, undefined behavior, memory management, that is totally testable. For the last 5 minutes, I am goofing off. So we're going to print, we're going to print some stuff. And let's do array 2, just for demonstration purposes. And then array at 2, easy. Gonna exit insert mode first, YY to yank, P to paste to get the same line again. And now I'm going to do R plus 2. What does it mean to add a number to an array? It means the exact same thing as array index, baby. But we can go further. Yank, paste. yank, paste. As I'm sure you loved and enjoyed learning in Math 1240, addition has the commutative property, so we can do this. But that means that array indexing has the commutative property. So we can do something that you should never put in any serious code. That's valid C.
So what does that do?
These 4 lines do the exact same thing.
Which is what?
Access or print the value at index 2 of the array. Oh yeah, I suppose it's worth going into this in a bit more detail just to review how printf works. %d is a placeholder for a decimal number, and then we give it the decimal number as a separate argument. Oh, I've been typing R because I'm used to the paper. Actually, scrolling is too much work. I'm going to search for R. Oh, this isn't going to work. Yeah, it just brings me to array. Okay, scrolling is an appropriate amount of work. Word, 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 word. Insert. A. And then I can actually repeat the same action, the same thing I did since being in normal mode, by pressing period, and keep doing that. Okay, just warning. Oh, this is actually something we should take seriously. This is just a memory location. You're going to get another sneak peek at later in the course with this. But to access the value that is at a memory location, we need to use this syntax. Don't worry if this is unclear right now. I'll explain it in more detail later. Like I said, I'm goofing off. Will it work this time?
Can I ask a question?
Sure.
Why didn't you just put the pointer just directly up beside the array? Plus
Oh.
2 plus the pointer. Would that work or no?
No clue. Let's try it. Visual, $sign to go to the end of the line, Y to yank, P to paste. And I guess we can't really change this unless we do that. Is that what you were wondering about? Okay. Now for the moment you've all been waiting for, I think. Warnings checkout. They're all 2. All of these lines do the exact same thing, and you now know more about arrays than you were ever meant to. Class dismissed.